So the reason when we're rationalising the denominator, it says we want a rational number, not a surd on the denominator, mainly because it's really hard to add if I've got a surd on the bottom of a fraction. We do it by multiplying the whole fraction by the surd part of the denominator on top of itself. So we're really just multiplying by 1. So this one is 2 root 3 times root 3 on root 3. 2 times root 3 is 2 root 3. And as we learnt just then, root 3 times root 3 is 3. So we're just multiplying by 1, a factor over itself, to get our denominator rational. The second example, it doesn't actually matter if I've got a coefficient of my surd down here. I'm still going to just multiply that by root 2 on root 2, whatever the surd part of my denominator is. That's 2 times root 6 times root 2. So that's 2 times root 12 over 5 times root 2 times root 2. So root 2 times root 2 is 2, times 5 is 10. You would simplify if you could. Root 12 is one that you can simplify. So that's 2 times root 4 times root 3 on 10. You can also simplify the 2 and the 10. Divide by 2 on the top and the bottom. So I've got root 4, which is 2, root 3 on 5. Other two examples are a little trickier. Here we've just got a surd on the bottom, so I'm still going to do 1 minus root 3 over root 3, and I'm multiplying by root 3 on the top and the bottom. But this is an expression times root 3. I would strongly recommend rewriting. That's root 3 outside of 1 minus root 3 on root 3. Don't get caught out and try simplifying, because your whole point was you've just multiplied by root 3. Expand out. Root 3 times 1 is root 3. Root 3 times negative root 3 minus 3 on 3. You can't factorise that to get rid of those 3's, because root 3 is not the same as 3. We can't get a factor there. We don't have a common one. This last one is the only spot where rationalising the denominator is tricky. We did go through in class why this works, but you've got an expression on the bottom, so not a product. A product was fine, but an expression, that's where we've got an issue. And you use the difference of perfect squares to get rid of it. So the same expression, but opposite sign, is what you're going to multiply by. And of course, that's bracket times a bracket here. This will need expanding. So I'd actually write it 5 times root 3 minus 1 on our binomial. Now, if we're feeling very clever, because we know that a difference of perfect squares is just square the first term, square the second term, and subtract, we could do a shortcut. If we're not feeling that clever, we'd just expand. 5 times root 3, 5 times negative 1. Root 3 times root 3 is 3. Root 3 times negative 1 minus root 3. 1 times root 3 plus root 3. You can see why these cancel out. 1 times negative 1 minus 1. The 2 inside terms cancel out, which has got rid of our surds on the bottom. 5 root 3 minus 5 on 3 minus 1, which is 2. So this is the hardest type of rationalising the denominator that I'd ask you to do, and it relies on that difference of perfect squares.